Magnets are not just for fridges anymore. From powered roller coasters to the literal guiding stars of the universe, they are multitaskers of the universe. Who knew they had so much pull? Let's look into it. Speakers and electric motors work because a current-carrying wire in a magnetic field experiences a force. The wire's current creates its own magnetic field which interacts with the external field to produce this force. Fleming's left-hand rule explains the direction, while the formula force is equal to build sine theta shows how the force depends on the angle. The magnetic flux density, however, varies with the setup. Beautiful sights such as the auroras like the Northern Lights are also caused by magnetic fields. Charged particles from the sun interact with the Earth's magnetic field, creating a light pattern near the poles. This is caused by the resultant force acting at right angles to the particle's speed and magnetic flux, which causes the curve. This theory is otherwise represented by the formula force is equal to BQV sine theta. Two wires flowing in the same way, besties, they attract. Opposite ways, they ghost each other. It states that parallel current-carrying conductors exert a force on each other due to their magnetic fields. Attraction for the same direction currents, repulsion for opposite. This principle aids in determining the current and power applications in electromagnetic cranes, where large currents in the electromagnet generate strong electromagnetic fields, creating forces that attract and lift heavy metal objects. Electromagnets also fall under magnetism as they generate magnetic fields when electric current flows through them. Unlike permanent magnets, their magnetic field can be switched on and off and adjusted by varying the current, making them versatile for lifting heavy objects or powering devices like motors or MRI machines. But we can't end this video without talking about Faraday's and Lenz's law. Faraday's law creates change. But Lenz's law said, not so much, buddy. Faraday's law says that change in the magnetic flux in a loop induces an EMF, while Lenz's law determines the EMF's direction opposing the change. Sounds confusing, right? For example, when a magnet drops through a coil, the increase in flux induces a current that resists the magnet's motion. As the magnet leaves, the flux decreases, and the current tries to pull it back. These principles power generators and magnetic brakes for roller coasters. Thank you for listening. I'm pretty sure by now we know that magnets do indeed pull.